Hello, students of Mr. Volkman. It is me, Mr. Mint, and I am here to introduce to you today's flip video lesson. It is on the geology of Washington State. Remember, this is an academic video, so please make sure you watch it in a setting where you can learn your best and to take notes the best. Don't forget, guys, to pause the video and rewind if you miss anything. And guys, don't be afraid to watch the video more than once. It's okay. That's right, Mr. Mint. Thanks for introducing the film. Specifically, we're looking at the history of the geology of Washington State. As we're watching it, please make sure you're thinking about in your mind what forces help to shape the landscape of our state. That's actually the 8th question on your outline. All right, ladies and gentlemen, I'd like to show you this North American paleogeographic map from a time long, long ago. More importantly, I want to show you where the coastline used to be on Washington State. Now, this map is hard to see Washington. This right here is British Columbia, or at least part of it, which means down here is part of Washington. You can see the Cascade Mountains. You can also see the Rockies. It's hard to tell, but this shows that the coastline is not where it is now. In fact, once upon a time, the coastline was eastern Washington. Now think to yourself, if the coastline was eastern Washington, where was Seattle? Where was Coupeville? All right, let's talk about some of the mountains in our state. First off, we have the Olympic and Cascade mountain ranges, the two major mountain ranges that are in Washington State. They seem like they could be very old, but in terms of mountain range age, they're actually young. The Rocky Mountains, which are our neighbors, are actually much older than the Olympic and Cascade Mountains. Here you can see where the Cascade Mountains go in the state of Washington. Another interesting fact about the mountains in our state is that they are a part of a bigger group of mountains, a group that's titled the Pacific Ring of Fire. Now, the Pacific Ring of Fire are made up of volcanic peaks, mountains that are actually volcanoes. Mount Baker, Glacier Peak, Mount Rainier, Mount St. Helens, and Mount Adams are all dormant volcanoes in our state. And if you take a look at this map here and chart, it shows you how often they have erupted over the last 4,000 years. Take a look at that map. Please pause the video and look closer at this chart. Let's talk about another geographic or physical feature of our state, which would be the Columbia Plateau. The Columbia Plateau was formed from repeated eruptions from fissures, which are cracks in the Earth's crust. Let me attempt to demonstrate through the wonderful power of Google Slideshow. Let's suppose that this line right here is the Earth's crust. Let's suppose that this yellow object is lava. So over time, lava spewed from this fissure and got higher and higher. Oops, wrong button there. Sorry, guys. But not only did it go on just the one side of the fissure, it went on both sides. So as you can see over time, I would keep piling up and up. This lava covered an area of over 100 miles. And if you can take a look, this is how big the actual Columbia Plateau is. It takes up most of Washington and parts of Oregon and Idaho. Now, what makes this area so fertile for the farmers on the Columbia Plateau is the fact that loess, or Louise, not sure how I pronounce it, which is volcanic ash, got blown on the wind and covered the ground, in some places up to 150 feet thick. Pause for a second on teaching you some information, and I want you to think about the big question that I mentioned at the start of this flip video, which is, what forces help to shape our landscape? And how did these forces shape our land? I'd like you please to pause the video, and if you need to, just think about that and jot some answers down for question 8. What forces help to shape our landscape? Moving on, with the rest of this flip video. I'd like to take a few slides to talk about the Mount St. Helens eruption that occurred May 18th, 1980. I'm not actually going to discuss and talk about what actually caused the eruption or the events that led up to the eruption. Instead, I want to focus on and talk about the effects of that eruption. First off, lahars, which are mud flows that carried huge debris such as logs of trees, actually huge trees, boulders, went into major rivers and blocked them. The Columbia River, in fact, got so blocked that ships were not able to go into it. As we can see, here's a picture of rivers being clogged. Here's a picture of a lahar covering a car. There was also a 12-mile high ash and gas cloud. As we can see from this map, it covered a huge portion of our country. Also, Spokane, which was 200 miles east of Mount St. Helens, had its visibility reduced to only 10 feet. Ice and snow melted very quickly as well during this eruption. Some other effects were the fact that tens of thousands of trees were laid flat. They weren't thrown, they were laid flat like dominoes, as you can see from these pictures. And some of these trees were like 6 feet thick. Now I'm about 6'4", so trees almost as thick as I am tall, and were 200 feet high, blown down like dominoes. Animals were killed, and unfortunately 57 people lost their lives that day as well for various causes. Here are two links, and you can definitely go on them. The first link was created by some of the men, the volcanologists, who studied Mount St. Helens and were watching it as it was getting closer to it erupting. And it's a very interesting film talking about how it erupted and what happened after. This here is live footage of someone who was actually on the mountain when it erupted. Now I say stop at a minute 57 because the guy who at the moment thinks he's going to die, he does start praying. So with it being a public school, I didn't know if I should show that portion of it, but if you're at home and you're fine with listening to someone praying, by all means continue watching it. It's nothing that's inappropriate. I'd like to talk about the glaciers, actually former glaciers that covered our state. In fact, glaciers at one point reached all the way down past Olympia. Now, you may think, oh, it's just ice. That's not too bad. Well, this ice in Bellingham was 4,000 feet thick. In Olympia, it was 1,800. So where we're at, we're kind of sort of in the middle. We'd be covered in ice. There'd be nothing. It would be so thick. Now, because of this ice, when times came for the ice to melt, it would cause huge floods and rivers would be backed up like the Columbia. And these waters in the rivers would have to find a way to escape, so they would go rushing and flooding all over the place. And that's kind of how the Grand Coulee was formed. Finally, fossil fuels. Coal is an example of a fossil fuel, and we have pretty sizable coal fields in Kittitas, Lewis, and Keene County. And fossil fuels are just formed from the remains of plants, prehistoric plants, that have been superheated and pressurized. Well, thank you for watching this flipped video. Please go to Edmodo, and I'd like you to answer the questions that are on there. Again, if you have anything you're unsure of, don't feel bad about rewinding and watching it again. Thank you, and have a great evening.
Did I miss it? Did I miss the video? Oh man, I always miss the video.